All right, in this lesson, we're going to do a review of area with conversions. Now, the reason I've chosen to do a review of this section is it's going to be necessary during the rest of your math course. You're going to need to use these elements, but it's also one of the areas that was maybe the weakest on your exam. So I wanted to take a little bit, I want to review it with you, make sure you understand, because it is something that the types of questions that involve conversions using areas could easily show up on a block exam. And there's a couple of conversions that I would argue, if you don't understand how to make them from a linear conversion, maybe you want to throw them on a memorize it list, a list of things that you really need to know in order to possibly be successful on your block exam. I know it's not math heavy, but you never know when those kinds of questions can show up, and they're questions that show up on a regular basis. So the first thing I want to look at is I've made a chart here to address some of the issues that come up. So the first question, anytime you're given a word problem where you're calculating area or whether you're calculating a volume, any kind of question that uses geometry is, or really any kind of word problem, doesn't matter if it's just a geometry question. Are the units given in the question the same as those requested for the answer? Always look for that. If yes, then you don't have to do any conversions, just use your known formulas straight through to the end. No need to change anything, no need to do anything. If the answer to that question is no, now we have to make a decision. So we're going to follow this tree. So if we say no, the units that I'm looking for are not the same as those that I've been given, you need to decide where are you going to do your conversion. You need to make a plan. There are two options. The first option is to convert before you calculate. Now, last term, I recommended that route. There's a couple of reasons. The pros for that route are there's less errors made by students. Okay, if you're just using linear conversions, usually before you calculate, you'll make less. If you convert before calculating, you'll make less errors. The downside of that is there's more numbers to convert. And as this semester becomes more complex, you don't want to be converting a huge volume of numbers. If you can convert one number at the end, it's going to be much faster than converting 3 or 4 numbers in between. So that's one of the cons of that. And you will always need to know the original dimensions. You can't just have somebody say 172 square inches is how many square feet. You're going to have to go, well, what was the length and what was the width of that particular object, convert those measurements. And that's not always logical or not always feasible. An example I can think of that is especially relevant, and this maybe is more on the carpentry line, is flooring in a room. So you know the area of a room. Let's say the area of a room is 900 square feet. And you need to know how many square yards because the particular flooring being installed is sold in square yards. Yes, you may not be a flooring installer, but that's still considered a carpentry question. You don't necessarily have the room dimensions on hand, but you need to be able to do that conversion. So how many square feet are on a square yard? If you didn't get that last term, you're going to get that by the end of this lesson. So that's the first option, is calculate before converting. And yes, less errors by students, but the disadvantage of more calculations, longer calculations, you always need to know your original dimensions. Option number 2, when the units are not the same, is convert after you've calculated. So keep everything exactly as is, do your calculations, and then at the end, make your adjustments. The pros for that side is it's typically faster. You've got less numbers to convert, so you've got less rounding, less error. Typically, you will get a much better number if you follow that route. The other thing is you do not need to have the original dimensions. The disadvantage, though, students often forget how to convert area and volume. I'm hoping that you'll have it remembered. Remember it by the time we're done. Now, for the purpose of this particular lesson, I am going to choose option 2 every time, mostly because I want you to remember option 2. I want that to stick with you. So option 2, we're going to convert after we calculate, and you'll see why I choose to convert after I calculate for most of these. So first of all, this is a question that I gave in a PowerPoint last semester. You guys had this same PowerPoint in January. I have edited the numbers in the second half of it. So there's a couple things here that are the same, but I know not all of you got it the last time. How many square inches are in a square that measures 1 foot by 1 foot? So this is really the premise. If you understand how to do this first question, you can do any area conversion. What this first question is really asking you to do is it's asking you to make a conversion factor. So I always recommend starting with a diagram. You know that, I've told you that many times. Let's start with a diagram. We have a square that measures 1 foot by 1 foot. Now, if you were thinking the area of this particular square, 1 by 1 gives me 1 square foot. Now, but it didn't ask for that. It asked me how many square inches are in a square that's 1 foot by 1 foot, or 1 square foot. So let's do a conversion. 1 foot is the same as 12 inches, and 12 inches here. Well, we could calculate this same square. We could calculate the area using inches instead. We can say 12 inches times 12 inches gives me 144 inches squared. This tells me that in 1 square foot, or I'll say these 3 little dots, we use them. It's, I guess, probably more of a calculus-y thing, or maybe from proofs, I'm not sure. I remember learning them in high school. 3 little dots written like this means therefore. So it's a way of writing a sentence in math. So we can say therefore, we can say 1 square foot, because that's what this was. This was 1 square foot, is equal to 144 inches squared. One easy way to make the conversion. If you have 1 square foot, you'll notice 12 times 12 is the same as 12 squared. So you take your linear conversion and you square it. So to convert an area, some of you probably would maybe like to have a sentence. So to convert area, multiply or divide, depends on your scenario, by the conversion factor squared. Okay, so that gives you a quick, and we'll test that. We'll do that a couple times as we go through. So the next question tells us we have a window with an area of 1,260 square inches. What is the area of the window in square feet? So we don't know the original dimensions. This forces us to use our conversion. So up above, we found that a square, that's 1 square foot, is equal to 144 square inches. So we can do this quite easy. Exactly the same steps as before. So 1,260 inches squared is what we start out with. Now, if normally we had inches and I wanted to go to feet, usually I would divide by 12. But this is square feet and square inches, so I have to use 12 squared. This is really, really, really important. Equals, we'll put that in, we'll write it out another way, just because if you don't want to use the squared in your calculator, we can say 1,260 is equal to, or 1,260 divided by 144. That will give us how many square feet? And that's 8.75 square feet. Now, I'm going to give you a memorize it one. Here's a memorize it. A memorize it for you is 1 square foot is equal to 144 square inches. That's a common one to use, and I would recommend throwing that on a memorize it list. But it's very easy if you think square inches, I have to take the 12 and square it, you're good. What that means I can give you another conversion and you'll go, oh, it's squared, therefore I need to square the conversion. So you can do this with multiple things. Let's look at the next question we have. So in this question, I'm giving you a new conversion, not one that we have memorized. You could calculate this, but for the sake of simplicity and rather than giving you multiple steps, I've given you a single calculation. There are 3.28 feet in a meter. That's a known fact. There's 3.28 feet in a meter. I have rounded it to 2 decimal places because we don't need any more precision than that. How many square feet are in 1 square meter? So basically what I'm saying is, okay, 1 square meter equals X square feet. We want to make a conversion. If you want to, make a diagram like before. This is our 1 meter by 1 meter. Well, that's the same as 3.28. Whoops. Let me adjust I wish the eraser on here was easier to access. It's not quite as easy as it is when you have a smartphone. So 3.28 feet and 3.28 feet. So 1 square meter is 1 meter by 1 meter. Okay, so there's 1 square meter is equal to 3.28 times 3.28. That's our feet. We'll put our units in there. Equals, just let's solve it. How many square feet are in 1 square meter? This is 1 meter by 1 meter. 1 times 1 gives us our 1 meter squared. 3.28 times 3.28. Those are both equal to a meter. So we multiply them together and we find that you get 10.76 square feet. So we could, and this is not a memorized one. This is not one you need to know. If it was feet to yards, that would be a good one to have memorized. 1 meter square is equal to 10.76 feet squared. So all we did to get that was we took this conversion factor. That's our conversion. We took it from here, and you'll notice it gets squared or multiplied by itself. That's how we do our conversion. If you have questions about that, please ask me. I want to know that you actually understand what's going on. So a house has 1,200 square feet of living space. What's the area in square meters? So again, we don't have the original dimensions. We're forced to use our conversion. So 1,200 square feet. I need to convert that equals X square meters. So from feet to meters, if you're not sure whether you should multiply or divide, set it up like the fraction. We want to get rid of feet, so we're going to put our feet in the bottom. We're going to put our meters on the top. They have to be square. The units have to match, and we can use the conversion that we just calculated. So 1 meter is 10.76, 10 76 hundredths. And if you just do the math, so that's going to be divide. 1,200 divided by 10.76 leaves us with 1.5 meters squared. Okay, 111.5 meters squared. So we're going to do a little bit with these area conversions. All right, now let's do a couple of questions where we dig back to formulas. Now, I have not given you the formula sheet, and I will not give you the formula sheet going forward for your formulas. You're welcome to look it up, but you will not be given formulas on your block exam. So you're going to want to work at memorizing those formulas, becoming very comfortable with them so that on a block exam, when you're not given a formula, you can still calculate areas and volumes. If you know how to calculate your areas, volume is one formula for all volumes. So that can be quite helpful. So what is the area of the floor plan below in square yards? So the first thing I said to do was check to see, are the units given the same as what you want? So the first thing here we see, we have feet, feet, feet. Everywhere is feet. So we will need to convert at some point. We can convert now. If you convert now, you'll see you have 6 measurements to convert. You're also going to get some decimals because 20 is not divisible by 3, and there are 3 feet in a yard. So where do you round? How much should you round? How much error can you get rounding? You can get plenty of that. So we're going to convert at the end. We're going to take option 2. We're going to convert last. So the first thing we want to do is find out what is the area in square feet, and then find the area in yards. So 1, look at area in square feet. Now I've written out the solutions for this, and I always hope that I haven't made a math error. Sometimes when I'm doing multiple solution keys at a time, I've been caught making a couple little errors, and I've double checked. But feel free, if there's something that you think is incorrect, let me know. So we're going to break this shape. I'm going to break it into two this way, simply because I'd rather calculate two shapes than three. I'm going to call this one area 1. I'm going to call this one area 2. So area 1, what is its area? Well, it's a rectangle, so I need length and width. So I need 20 and 12. So area 1 is 20 feet by 12 feet, gives me a total of 240 square feet. All right, and we never use the symbol when we write square feet. We always do feet and then our little squared like that. You never use the apostrophe for square feet. Area 2. Let's calculate that. Well, we need a length and a width, so 8 and 34. This 7 is really extra information for us. We do not need to have at this point. So 8 feet by 34 feet gives us 272 square feet. Now we need the total. So adding those two together, I get a total of 512 feet squared. But that's not what the question asked. The question asked for square yards. So we need to figure out how many square yards, how many square feet are in a square yard? Because we know there's always more feet in yards. So you know that 1 foot, sorry, let me say this backwards. Sometimes I get off when I say things backwards. So we know that 1 yard is equal to 3 feet. Okay. So if you have 1 square yard, do you remember what I said you're going to have to do the conversion? You will need to square it. So 1 square yard is the same as a square that's 1 yard by 1 yard, or 3 feet by 3 feet. 3 times 3, 3 squared. So 3 times 3 feet squared. That gives us 9 feet squared. Okay, so we're just taking our conversion, the normal 3 that we always use, and we're squaring it. So we're multiplying it by itself. That's what comes from this picture. So I started out with 512. I want to convert that into yards, square yards. So I need to multiply. Let's use these numbers in a fraction. So we know 1 yard squared is 9 square feet. Put the feet on the bottom, so the feet and feet cancel. So it's the same as 512 divided by 9. Usually to go from feet to yards, you divide by 3. So you're just dividing by 3 squared, which gives us a total of 56.9 square yards. So not an overly complicated calculation, really pretty straightforward, but using that conversion and squaring it is really, really, really important. All right, another question. I've got 3 more questions for you, all quite straightforward. I may not spend quite as much time on all of them. What's the area of the figure below in square feet? So we have inches, and we want to end up in feet. Now this one's only 2 conversions. Maybe you want to switch it right at the beginning. You could if you wanted. But from our memorize it list, we know that 1 square foot is equal to 144 inches squared. That 144 is just 12 squared. So it's the same, 12 inches in a foot, 12 squared gives me square inches in a square foot. All right. So we're going to use this, but we're going to save it to the end. We're going to do all of our calculations first. I have area 1. I have area 2. Area 1 is a nice, easy one for us to calculate, and I think all of you have that memorized. So 15 inches by 10 inches leaves me with 150 inches squared. Area 2 is a half of a circle. So we're going to start out with half, and then our formula for the area of a circle, which is pi r squared. The radius of this half circle, so the radius of this half circle should go here, equals 5 inches. You'll notice it's half the width of the rectangle, so we got 5 inches. So we'll plug that into our formula. Half, you can use the letter pi, or you can put 3.1416 times 5 squared. Putting all of that into your calculator, you will get 39.27 inches squared, and our total area 1 plus area 2 is equal to 189.27 inches squared. Now we have to switch to square feet. So our question isn't done. You have half marks now, but you don't have full marks. So to go from inches to feet, we're going to divide by 144. You can set it up like the unity fraction, like I did on the last couple. Feel free to do that. If you're not sure whether you're going to multiply or divide, but I'm going to guess most of you at this point know from inches to feet, you divide by 12. So it's the same. You're going to divide by 144. You're going to divide by that 12 squared. Leaves us with 1.31 square feet. All right. Hopefully you're getting the hang of it. There was a bonus assignment with this stuff for the last course. There was a large number of people that didn't even look at it. And that's okay. It was a bonus, but it would be really, really helpful right now. So you're going to see some of the same questions show back up. And one of the last couple. Now, the next couple questions use trapezoids, and I'm going to use trapezoids quite a bit in the next little bit, simply because the block exam loves to use the trapezoid formula. Not sure why, but it is one that is often seen. So you'll see the bottom of this, we have a rectangle. So I'll call it a rectangle area 2, and I'm labeling it area 2 only because it's area 2 on my sheet that I have my notes pre-done on. The top here, this is a trapezoid, so you have 2 parallel sides, and then this one is, it's okay that this one is at a right angle and this one's at a diagonal, that's absolutely fine. And this dashed line is really supposed to be coming from here. It's not a terribly well-drawn diagram. And there's area 1. What is the area in square yards? Well, the first thing we do, if we recognize it's a trapezoid, area 1 is equal to, well, trapezoid is big B plus little b, big base plus little base, divided by 2 times the height. So if we plug some information in, our big base is this length here, and that's 22 feet, plus the little one is 8 feet, divided by 2 times the height. Now the height is this height here. Now we know it's 16 feet altogether. There's 12 feet on this side. So this must be 16 minus 12, which is 4 feet. So that's our height. Putting all of that in your calculator, follow order of operations. Make sure you do that 22 plus 8 first, then divide it by 2, and then we multiply by 4. That will give us 60 square feet. Area 2. Area 2 is a nice easy one. We only have a rectangle. So we have 22 by 12. So we use the 22 and the 12. We don't want to use the 16 because the 16 is more than just the rectangle. So 22 feet by 12 feet leaves us with a total of 264 square feet. Total, we add area 1 plus area 2 together, and we get 324 feet squared. Now, we want to know in square yards. Do you remember the formula for square yards? 1 yard by 1 yard is the same as 3 feet by 3 feet. So 1 times 1. So 1 yard squared has to be equal to 3 times 3, which is 9 feet squared. This one is a memorize it. That's a good memorize it one. That's one that's commonly used, especially for carpentry. For programs like HVAC, The square inches, they use inches more. Square inches, cubic inches, both of them, but for carpentry, the yards is used quite often. So we have feet, we want to get to yards. Normally when we have feet and we want to get to yards, we divide by 3. So we are going to divide by the 9. Equals. We divide by 9, we get 36 square yards. Okay, so we're dividing by 9. 9 is the same as that 3 squared. Sometimes I will write it up this way, 324 feet squared. And I think, okay, feet to yards, I have to divide by 3. It's squared, so I got to square the 3 equals 36 yards squared. It's a really simple way to think of it, but it does seem to stick, and it's worked really well for students in the past. It's just thinking about, okay, usually I divide by 3, but the unit squared so I could square the conversion. And that often helps. If you're struggling with that, try that trick. All right, last one. Some of you might recognize this question. I gave this exact question on the exam. Some did it exceptionally well, but not everybody. So I am pulling this question back out. This question may have looked like, heck, I've never seen that before. But you had. If you take a look, especially if you look at the book, so there's a couple ways to approach this. You could look at this as, you could break it here, and we could look at this as being 2 triangles with a rectangle in the middle. Fair, and whatever's on this side, it's symmetrical with the other side. That's perfectly acceptable. Did you do triangles? Yes. Did you do rectangles? Yes. So that's one way to do it, but that's not the way I'm going to do it. Told you I was going to bring up trapezoids. If you take a look at this shape again, you may see, if you ignore the triangle on the edge, that this shape, the whole thing, is one large trapezoid. So basically you have 2 trapezoids that are the same. And that's the easiest way to calculate it. It's just to use this and say, okay, I think that's an A there and not an E there for trapezoid. Spelling was never my forte. Okay, so we could say that's a trapezoid. We can use our trapezoid formula. So the trapezoid formula says that area is equal to, I'm going to call it area 1. So we're only doing half of it at the beginning. Area 1, which is the big base plus the little base, divided by 2 times the height. Big base is 20 plus 13 divided by 2, and those are in inches. So we'll throw my units in. You put your units in, you remember what units you're getting out, times a height of 5 inches. If you put that into your calculator, I have 182, whoops, 182, it's 82.5. 82.5 inches squared. So the total area is going to be double that. So 2 times 82.5, which gives us 165 inches squared. Now, if we look back, we have how many square inches is the area? Great, love having that, but it wants square feet. So let's do our conversion. This is one of the memorize it ones that would be really nice for you to know. So 165 inches squared. To go from inches to feet, usually I would divide by 12, but I can't divide by 12. I have to divide by 12 squared because this is squared. Or 165 inches squared divided by 144. That's 12 squared. Equals 1.14 feet squared. And that's actually a really reasonable number if we kind of look at the shapes that we have here and the sizes of things. You know, this line here is longer than a foot. It's almost a half a foot tall. But we also know this 20 means these triangles are fairly large, and you kind of start putting it together and you know, yeah, that makes sense that it's close to a foot square just by looking at the picture. So hopefully that gives you a bit of a refresh that kind of freshens those things up. Make sure you can do that quiz on converting areas. Converting areas is going to be extremely important for you moving forward, and it is something that to many of you will be important for your block exam. So please take the time to actually make sure you understand it. And if you have questions, don't hesitate to ask. I'm more than willing to go through things with you independently. You can stop by my office, shoot me a message, whichever it happens to need to be.